Hey everyone, Jeremy here. I'm excited to guide you through a journey that takes your ideas from the screen to something you can actually hold in your hands. Have you ever designed something cool on your computer and wished you could hold it, see how it feels, or even use it? That's where CNC machining comes in. It's the bridge between your imagination and the real world. But before your idea can become a real part, you need a manufacturing drawing. Think of it as the universal language that connects you and the machinist, making sure your vision is understood exactly as you intended. Without a clear, detailed drawing, you're just guessing, and so is the machinist. That can lead to mistakes, wasted time, and parts that don't work. This guide is designed for beginners, students, hobbyists, inventors, or anyone who's ready to turn digital designs into real, functional parts. We'll break down the process step by step, starting from your 3D model and ending with the final PDF drawing you'll send to the machine shop. You'll learn how to lay out different views, add precise dimensions, and include all the notes and details machinists need to make your part exactly right. By the end of this guide, you'll have the confidence and skills to create clear, complete, and professional manufacturing-ready drawings. Mastering this skill opens up a world of making. Suddenly, your digital dreams can become real objects you can use, share, or even sell. So grab your CAD software, get comfortable, and let's get started on this exciting journey together. Remember, every expert was once a beginner. Mistakes are just learning opportunities, and every error brings you closer to mastery. Let's dive in and make your very first professional blueprint. Your journey to making real parts starts now. What is a manufacturing drawing? It's more than a picture. It's a contract that tells someone exactly how to make your part. It includes shape, size, material, and any special treatments. CNC machines are precise, but they need clear instructions. Your drawing is their guide. If your drawing is unclear, the machinist has to guess, which wastes time and money. A good drawing removes all guesswork, ensuring you get exactly what you designed. Think of it as a recipe. Every detail matters, from material to exact hole size. Drawings follow standards, a universal language machinists everywhere understand. By learning these standards, you're learning to communicate in the world of manufacturing. This skill is valuable no matter what you plan to build. Before you start a drawing, your 3D model must be complete and accurate. If the model is wrong, everything else will be too. Double-check every feature. Holes, fillets, dimensions, nothing should be left undefined. Make sure your model is fully constrained so it won't change accidentally. Use your CAD software's tools to check for errors or weird geometry. A clean, robust model makes the drawing process smoother. Think about manufacturability. Can tools reach every surface? Are inside corners machinable? Design for manufacturability saves time and money. Great designers think about how parts will actually be made. With your 3D model ready, it's time to start a new drawing in your CAD software. This is the foundation for communicating your design clearly and professionally. Choose a sheet size that fits your needs. A3 or A4 is usually best for small to medium parts, offering enough space for details without being overwhelming. Use a standard template that includes a title block. This is where you'll enter key information like the part name, part number, material, who drew it, and the date. Keeping this info accurate is essential for tracking and collaboration. Next, select your 3D model to place on the drawing sheet. This links your design to the drawing and ensures accuracy. Before adding any views, take a moment to plan your layout. Think about how to arrange views for maximum clarity and logical flow, so anyone can understand your drawing at a glance. Check your projection standard Third angle is standard in North America, while first angle is used in Europe and many other regions. This choice affects how your views are displayed. Set the projection method correctly and make sure it's clearly noted on your drawing, usually in the title block or a dedicated symbol. The projection standard determines how your views are arranged on the sheet, so double-check this to avoid confusion. A well-organized sheet with clear labels and logical structure makes everything easier to read and reduces mistakes during manufacturing or review. Don't skip these basic setup steps. They set the stage for a professional, effective drawing that others can trust and use. Now you're ready to start placing your views and building out the rest of your drawing. Now it's time to place your part's views on the drawing sheet, a crucial step in making your design easy to interpret. Always begin with the base or front view. Choose the orientation that best displays the most important features and details of your part, as this will serve as the foundation for the rest of your drawing. Place this front view in the bottom left area of your drawing sheet. This strategic placement leaves plenty of space for projecting additional views, ensuring your layout stays organized and readable. Next, use your CAD software's projection tools to add the top and right side views. This follows the third angle projection method, which is the standard in many industries and helps others quickly understand your design intent. Only include the views that are absolutely necessary to show all the features of your part. Adding extra, redundant views can clutter the drawing and make it harder to read. Remember, clarity is always the main goal. If a feature is already clear in 2 views, there's no need to add a third. Fewer, well-chosen views make your drawing more efficient and easier to interpret. Always include an isometric view in the top right corner. This 3D reference helps anyone looking at your drawing quickly visualize the overall shape and form of the part. While the isometric view isn't used for dimensions, it's extremely helpful for machinists and fabricators to understand how the part should look when finished. A clear, well-organized layout bridges the gap between your 2D drawings and the real 3D part, making manufacturing and inspection much smoother. Keep your drawing simple, focused, and free of unnecessary details. A clean presentation is always more effective. Choosing the right views and arranging them thoughtfully makes your technical drawing easy for anyone to understand and use. Sometimes standard views aren't enough. Complex internal features can get lost in hidden lines. Use sectional views to cut the part and reveal the inside, turning hidden lines into clear, solid ones. Draw a cutting line and your CAD software generates the section view with hatching for solid areas. For tiny, important features, use detail views. Zoom in on a small area for clarity. Label and scale detail views so dimensions are easy to read. Sectional and detail views show you care about clarity. They make life easier for the machinist. Clear drawings lead to correctly made parts. Now add dimensions, the most critical step. Dimensions tell the machinist exactly how big and where every feature is. Only provide the dimensions needed to make the part. Don't over-dimension. Start with overall width, height, and depth, then work inward to features. Use common datums, edges, for consistency. Keep dimensions neat, organized, and avoid crossing lines. Use CAD tools to align and space dimensions for readability. If a view is crowded, use a detail view. For holes, specify diameter, depth, and thread type if needed. For repeated features, dimension 1 and note how many times it repeats. Clarity and precision are key. A clean drawing is a professional drawing. Next, add tolerances, materials, and finishes. Tolerances define acceptable variation. No part is made to an exact number. Add tolerances directly to dimensions or as a general note in the title block. Use tighter tolerances only where needed. Precision costs money. For advanced control, learn about GD&T, geometric dimensioning and tolerancing. Always specify the material. Be exact about alloy or plastic type. Material affects strength, weight, and machinability. Don't forget surface finish. Some areas need to be smooth, others can be rough. Indicate finish with the proper symbol and roughness value. General finishes can go in the title block, special ones on the drawing. Missing this info leads to costly mistakes. These details ensure your part is made right. Don't leave them out. Last step, review and export. Fill out the title block. Part name, number, material, tolerances, your name and date. Use the revision block to track changes. Update it every time you revise the drawing. This prevents manufacturing outdated parts. Review your drawing as if you're the machinist. Check for missing info, errors, or unclear details. Print it out to spot mistakes you might miss on screen. Get a second set of eyes if possible. When you're confident it's complete, export as a PDF. Name the file clearly with part number and revision. Now you have a professional CNC-ready drawing. Congratulations, your design is ready for the real world.